Alright guys, so welcome back. This is our third part of our simplifying radicals lesson. Our first part was the introduction where we explained what a radical expression was. Our second part involved simplifying radicals that had no variables in the radicand. And now we are simplifying radicals with variables in the radicand. So we are going to, for now, stick to perfect squares, or square roots, sorry, and factor by perfect squares. So if you are factoring variables, it's a little bit different. We can make it a little different than the perfect squares method. So we'll do both methods. So let's go with x squared. X exterior parentheses squared is just x squared. Square root of x squared, remember the nth root of anything to the n is that number. So x square root of x squared is x. All right, so we have x squared squared. So notice how all of the top row have a squared on the outside of the variable. That's basically, we're squaring what's inside the parentheses. Now, we did discuss laws of exponents earlier in the year. So remember when you have a power to a power, you multiply the exponents. So x squared, 2 times 2 is x to the fourth. Okay, and the square root of x to the fourth, well, x squared times x squared is x to the fourth. So x squared is the square root of x to the fourth. And we have x to the third squared. Remember, 3 times 2. So it'd be x to the sixth. Square root of x to the sixth is x to the third. X to the fourth squared is x to the eighth. So the square root of x to the eighth is x to the fourth. X to the fifth squared is x to the 10th, because 5 times 2 is 10. X to the 10th, so square root is x to the 5th. And then x to the 6th squared is x to the 12th. And the square root of x to the 12th is x to the 6th. So it asks you to think about, what patterns do you notice? So let's think about that. All right, so what we hope you noticed is that a square root means half of the exponent, okay? So that works when you have an even. So perfect squares always have even exponents. Now, a quick tip. Easiest way to do this would be to divide the variable by 2. Now we could do that with any index, just divide it by the index, and whatever's remaining stays inside the radicand. So we'll go ahead and do a couple of examples with squares, and you'll see what I mean when I say that. So the number before the decimal is the exponent of the variable outside. So what that means is if you divide it by 2 and you have a remainder, what's in front of the decimal goes outside, and then that lets you know what the remainder is. So if the number after the decimal is 0, there is no variable inside, and if it's 0.5, the variable with power of 1. And we'll have a couple of examples to go. All right, so let's try a couple examples together. So the first one we have is square root of 49x to the squared, x squared, x to the second. So what we're going to do is we're going to factor both the 49 and the x squared. Now, both of these are conveniently perfect squares. So the square root of 49 is plus or minus 7. And the square root of x squared is x. And the way we can write that out to show our work, if we are struggling at any point, is to put 7 times 7, x times x. And remember what we said in the last video about murdering the partners. So remember, this is an index of 2. And so we're going to look for pairs. This 7 wants to come outside. He can do that, but only if he kills his partner. We have this x. He wants to come outside, but again, only works if he murders the partner. So we on the outside would have 7x, and we keep the plus or minus because, of course, every square root has two square roots, or two answers, positive and negative. All right, so we're going to go to do the square root of 200b to the 8th. So we have 200 is 1 and 200, 2 and 100. So we have a perfect square already. Now, of course, we could do 200 divided by 2, divided by 2, divided by 2, divided by 2. That would get tedious, so we're not going to do it that way. We'll do that example with a smaller number. All right, so we're breaking this down to the square root of 100 times the square root of 2. That's for our numbers. And then we have square root of b to the 8th. B to the 8th. Now, as we looked earlier, we could just divide this exponent by 2, and it would be an even number. So 8 divided by 2 is 4. So our new exponent will be b to the 4th. So square root of 100 is positive or negative 10 times this b to the 4th, because that's going to be outside, square root 2. So that's a lot for just one little part of this, but we get the hang of it. So let's go ahead and do the next one. Okay, and you'll notice I went ahead and rewrote the answer to the 200b to the 8th with parentheses, and that is to remind you that it is very important that it is noticeable where your exponent is. It needs to be with the variable, not in the index. So we need to make sure we don't accidentally put the index or the variable over the v of the radical symbol. So now we're going to do square root of 75 m to the 3rd n to the 4th, and we're going to do each of these parts. So we're going to factor 75. So that's 1 and 75, 3 and 25. And again, we have our perfect square here. So we're going to factor m to the 3rd. So if we want to do that, it's going to be 3 divided by 2. So m to the 1.5. So remember, if it has a 1, any number in front becomes the exponent on the outside. And if there is an exponent on the half an exponent, a variable with an exponent of 1 goes on the inside of the radical. All right, and then so n to the 4th. And so it's going to become n to the 4 over 2. And 4 divided by 2 is 2. So n to the 2. All right, so we're going to break down our 75. So 75 is the square root of 25 times the square root of 3. So square root of 25 is plus or minus 5. And then we want our variables to come in before we write our square root. So we had 1m on the outside, n to the 2nd on the outside. And I'll go ahead and put that in parentheses. And then what we had left was the square root of 3 on the inside and an m on the inside. So our final answer becomes plus or minus 5mn squared times the square root of 3m. All right, the next one we're going to do is 12hk to the 3rd. So again, we're going to factor 12. And so this time what I'm going to do is I'm going to do the prime factorization of 12 and the prime factorization of everything else. So 12 divided by 2 is 6, divided by 2 is 3. So 12 is 2 times 2 times 3. We have 1h, and we have 3 k's. Okay? So for the prime factorization of the variables might be easier. So again, remember, we are going to look for partners, and then one can leave the house if they kill their partner. So here is a pair of 2's. Again, this first 2 can leave if he kills his partner. There's only one 3, only one H, but here's a pair of Ks. One K can come out only if his partner is eradicated. So we had a 2 and a K on the outside. And then on the inside, we have 3 H K. So our final answer is 2K times the square root of 3HK. All right, our next one has a coefficient in front. So remember, coefficients will just be included as part of the outside. So I'm going to go ahead and transfer that 4 over. And I'm going to put my everything that's on the outside in parentheses. And then I'll have my square root of something. Okay? So we're going to factor 50. And I'm going to do prime factorization because it is easy enough. So divide by 2 is 25. And then 25 is not divisible by 3, so 5 and 5. So 50 is 2 times 5 times 5. And then we have 5 x's inside. 3, 4, and 5. And we have 9 y's inside. 2, 3, 4, 5, 6, 7, 8, 9. Okay? And so again, we're going to find partners and murder victims. Right, so we have a pair of 5s right here. Again, one of the 5s can come out, but only if he kills his partner. And we have one pair of 2s, two pair of 2s, or x's, sorry. One x can come out if he kills his partner, and 2 x's can come out if they kill their partner. So we have x squared. And then let's see how many pairs of 2s. 1, or y's, sorry, 2, 3, 4. And so we will take this y and kill this y. Keep this one, kill this one. Keep this one, kill this one. Keep this one, kill this one. And the last y doesn't have a partner, so he doesn't have to murder anyone. He's going to stay home. So we had 1, 2, 3, 4 y's. And then what we had left in the inside? We had a 2, we have an x, and we have 1 y. So 2x, y on the inside. Now that looks like we would be done, but unfortunately we're not, because we still have to multiply the 4 times the other coefficient. So 4 times 5 is 20, and then the rest of the variables stay the same. X squared, y to the 4th, and then the radical and radicand stay the same as well. 2x, y. All right. So the next lesson is going to be the next problem is actually something that kind of applies to the next lesson. We'll go ahead and still do it just so you're prepared, but our operations with radicals will cover this in more detail. So we have two radical expressions here, and they're being multiplied by each other. So what we actually have to do is combine everything together, or we can factor them separately and see what we end up with. What I would like to do is take the numbers separately and then combine all of the variables inside. So we're going to have the square root of 4 times the square root of 243. And then we're going to multiply the m's and the n's together on the inside. So we have 7 m's in the first term and 3 n's in the second term. So we have n to the 10th. And then we have 1 m in the first term and 12 in the, or 11 in the second. So we have m to the 12th. All right, and I'm not going to write out 10 m's and 12 m's. All right, we're going to do the division trick on this one. So easy enough, the square root of 4 is going to be 2. And 243 we need to factor. So we have 243 is going to be 1 and 243. It's not divisible by 2 because it's not even. So let's see, 4, 6, okay, 3 is 81. And there's a perfect square right there, so we're going to stop. So we're going to have square root of 81 and square root of 3. And then we are going to have n to the 5th. The square root of n to the 10th is n to the 5th. And the square root of m to the 12th is m to the 6th. And so now we're going to divide what or multiply what we have. So we have 2 times 9 equals 18. And then we have n to the 5th, m to the 6th, and the square root of 3 is going to stay square root of 3. So our final answer for 4n to the 7th m, or sorry, square root of 4n to the 7th m times the square root of 243 n to the 3rd m to the 11th is going to be 18 n to the 5th m to the 6th times the square root of 3. And that's the final answer there. Now, there are several questions here they want you to try on your own. So what I'm going to recommend is trying these out, and if you need any help with them, shoot me an email or talk to me on the Google Hangouts. But for now, we're going to stop there because that's 6 examples. I think we should be adequate here. Make sure you do the scavenger hunt that is uploaded to the classroom and get it turned in as soon as you can. We'll put our next lesson up as soon as possible, and everyone have a great day.